Thank you, everybody. My name is Jim Walker. I'm in product marketing here at Cockroach Labs. I love what I do here. It's helping people understand kind of the value prop of what we do and translating some of the core, deeper technical concepts into more kind of consumable versions of them. But I'm joined today by Keith McClellan. Keith, you want to give a quick intro of you and your role here at Cockroach?
Yeah, so I am in charge of the solutions engineering work we do with the partners and broader technology ecosystem. Almost 100% of that is Kubernetes-based stuff. I'm one of the maintainers of the Helm chart, for example. I'm one of the people that worked on the development for this most recent, the new operator we deployed. I was also one of the maintainers of the previous Helm chart based operator that we had for folks to use last year. So I'm looking forward to talking more about Kubernetes today and how we support Kubernetes at Cockroach Labs.
Right. And Keith, you come from a background in Kubernetes, right? So how long look at Kubernetes, how old is Kubernetes? 5-6 years, right? So, or like really, seriously?
Yeah, something
right.
like that. So
I forget what the birthday was, but how long have you been involved in the Kubernetes community?
Yeah, so I used to work at a company called Mesosphere that was the Apache Mesos company. Mesos was kind of a precursor to Kubernetes, right? So Google invented Borg. Then there was this Apache project called Mesos that tried to provide some of the same scheduling semantics there. And then kind of Kubernetes came out of Google. So Mesosphere was a kind of a founding member of the CNCF. Right. So I think the first time I touched Kubernetes was early 2016. And of course I've been largely focused on the Kubernetes ecosystem since I joined Cockroach Labs as well. Yeah. So I would say my expertise has come a long way in the last few years. But the cloud native ecosystem, a lot of the same design patterns apply for both Kubernetes and some of its precursors. So a lot of experience there.
And I ask Keith because honestly, I think everybody's looking to learn and kind of get some decent understanding of Kubernetes. My own journey, I think I first got introduced to Kubernetes. Gosh, I was at Hortonworks when they were first talking about it. And that was a long time, 2013 or so. No, when they first announced the project, I remember I had to write a blog post for our CTO at the time about what it meant for us. And we had Yarn at the time, if anybody's familiar with it, it is a kind of our resource management kind of thing. I understood the layers and everything. I just didn't understand Kubernetes. And I got to tell you, it took me some time to actually really get my head around Kubernetes and what it means. And I think where people struggle, in my opinion, I don't know about you, Keith, but it's paradigm shift. This is a really truly different way of thinking about systems from just a distributed systems point of view, but from orchestration as well. And I think that's where people, once you get over that hump, things start to make a whole lot of sense. I was lucky enough to work at a company called CoreOS as well. That team and some of the stuff that happened there was just phenomenal in terms of driving that early phase of Kubernetes. I mean, I think I've been to every KubeCon except Copenhagen. So it's fun. I'm not at it today because I'm on the session with everybody here today, but I shout out to everybody who's helped me understand this. And I hope that this is valuable to everybody on the phone today so that, the Kubernetes community is one of these that's very special. I think I don't know about you, Keith, but I'm proud to be a member of it because I think a lot of people are very helpful in the community. I think there's a lot of contribution and there's a real strong sense of humility and contribution in the Kubernetes community, right? So speaking of, let's just start there. Funny enough, about a half hour ago, somebody that I respect like crazy and I've learned a whole lot from, if you're in the Kubernetes world, guy by the name of Kelsey Hightower, who, man, he speaks at every KubeCon, everything. He posed this question actually, or he stated this on Twitter earlier today. Stateful applications running in Kubernetes can help close the gap when it comes to horizontal scalability, configuration, and data recovery. I think there's two things here that I love about this quote, Keith, and scalability and data recovery, which I think of as survivability. But I also love that, hey, CockroachDB is a good example of this because we are. And, I think this is a really good place to start. So I'm going to stop sharing, Keith, so that, there's my wrap up slide. You guys can't see that yet. Let's see, stop share. So now it's just us on here. So let's start there, Keith. Let's start with, workloads and stateless workloads and these sort of things. And, you've seen companies use orchestration systems, be it Mesos, be it Kubernetes. What is the state of, transactions and workloads on Kubernetes today? How would you characterize it?
Well, for most folks, it's still really challenging, right? So there are kind of two paradigm shifts that happen at once with Kubernetes. The first is we're running on other people's computers. That's what the cloud is.
Mm-hmm.
And that means that we don't have the same command and control over the infrastructure that we would if we were managing in our own data centers. This is a big deal, right? Because you're not necessarily going to know if there's maintenance that's going to happen on a particular machine or a rack. You don't know when AWS or the GCP is going to potentially push out a config change that you may need to work around.
Yeah.
So how do you manage that infrastructure when it's always there, but any particular instance or machine isn't necessarily as reliable as it would be if you're running in your own data center. And then the second piece of it is you add Kubernetes, and Kubernetes doesn't even guarantee that you're running on any particular node at all. So how do you run an application when you're not sure if any particular instance is going to be around at any particular moment, right?
Right.
This is hard for stateless applications, right? Not only do you have to have a lot of different copies of the same app, they have to be they need to be small enough that they're easier to manage and maintain and scale. But you also have to do a lot of complex stuff around load balancing and service discovery and supporting failure modes and all kinds of different stuff there. So and that's just for stateless applications. That's for your static web app. That's for your a microservice. What do you do when you add state? State is the thing that makes a machine or an instance or an application special, right? So if you go back, you take a look at some of the kind of the early cloud native discussions. It's the, cattle versus pets conversation, right?
Yep. Yeah.
So as soon as you have something that's unique about a particular instance or machine or application, all of a sudden you have to treat it like a pet, because if it goes away, it's hard to replace. So CockroachDB provides this kind of underlying replication layer that guarantees that you're never going to have a scenario where a specific server or instance or node is going to be so special that you can't survive the loss of it.
That's right.
So, and then we can then extend that design pattern out past nodes. We can extend it out to fault domains, think availability zones, or think whole regions, even if you want to be able to survive an entire region failure.
Right.
You have to do that to be able to have a highly available stateful application in Kubernetes.
Mm-hmm.
There are an enormous amount of solutions out there for quote unquote HA Postgres, HA MySQL, that kind of stuff. But all of them are really kind of automated disaster recovery at best. You're not guaranteed that you won't have lost a transaction, and you're not. So it's things like, oh, you have auto failover to a backup pod. That's great. And hopefully your state is in sync, and hopefully that other pod is consistent. But
right.
Because of the way that those databases were designed when they were developed 15, 20, in Postgres's case, you're going back 30 plus years.
Right.
there's no strong guarantees there that you're going to have a recovery point of exactly when you had your failure.
Right.
Database parlance is RPO, recovery point objective of 0, right? With CockroachDB, we're doing synchronous replication, and we're maintaining multiple replicas using a consensus algorithm that we share with etcd. So we maintain consistency across the nodes in CockroachDB the same way the Kubernetes cluster itself maintains consistency. If you were to have kind of a control plane failure, they use a small kind of key value store called etcd, which is great for configuration management. We're using that same replication protocol for and consensus algorithm for maintaining state across a SQL database.
Right. So Keith, let me pull a couple. That's a long
yes
monologue. Okay. So let me pull a couple things out of that. Right. And let's drill in a little bit more. So, I think etcd is one of these core principles that people need to understand about Kubernetes. I like to think of it as like the brain. It's like where you set state, and basically it helps you kind of understand the entirety of kind of what's happening in your cluster of a Kubernetes cluster. But we talk about state, and we talk about, there's stateless applications, and then there's, what we all code, which is like stuff that goes against the database. It's state. Like you need state. Like, I mean, come on, right? Like a web server, nobody's building a web server every day. So I think there's kind of certain things that are kind of interesting there. One of the questions that came up, and I want to actually make sure we speak about this, is, there's these concepts of daemon sets and stateful sets in Kubernetes, and stateful sets, I think helps us a whole heck of a lot in Cockroach, right? And so, can you describe what daemon sets and stateful sets are in the context of these stateful applications and what they're used for in Kubernetes?
Yeah, so there are actually 3 primary patterns for joining a particular set of state to a particular instance of an application or a pod.
Right.
Okay, so and the high level primitive is a set primitive, which basically binds some volume, whether it's a cloud volume or a local volume or whatnot, into a pod so that you can kind of maintain state across restarts for any.
And basically, you're just using the storage class for that, right? And you use PV or PV claim, whatever, so that you can mount storage.
Yeah, we'll get to that because that adds some complexity to this whole thing, because there are so there are kind of 3 types of sets, right? You have what's called a replica set, you have a stateful set, and then you have a daemon set. I think there are actually other set types, but these are the 3 most common types of sets that you're going to use in Kubernetes. So a replica set is let's say I have a config file that I need to mount into my otherwise stateless application, and I'm going to run 50,000 copies of this container. But I need to inject the same state into all 50,000 copies of that container. I'm going to use a replica set for that.
Right.
So it's effectively a one-to-many, think read-only mount. If you need to make changes to the state, you can change it in one spot, and then it gets pushed out to all the replicas, that kind of stuff. Very useful for lightly stateful things. The canonical example is usually things like config files, right? Then you have something called a stateful set. That's what we primarily use with CockroachDB, where you're going to have an arbitrary number of pods. Each of those pods is going to have some unique state to it, and you want to be able to reattach that state to a pod after a restart, right? So what that does in the back end, depending on how that storage is mounted, it creates certain kind of failure and restart triggers. And that's where we get into storage classes and PVs and PV claims and all that kind of stuff. And they're, depending on how you have all that set up, depends on how flexible that particular pod restart is, right? So if you're using a local disk for your persistent volume, and the persistent volume claim is effectively what attaches that's what the stateful set uses to attach the volume, the actual state, to the pod.
Right.
So if you're using a local disk, then that pod will only ever restart on that particular node, right?
Right.
If you're using, say, offboard storage, using EBS volume in AWS, you're using maybe kind of like a vSAN in maybe a private cloud environment, something along those lines. You have more flexibility. So as long as that persistent volume has been unmounted, the persistent volume claim and the stateful set can go and remount that volume on a different server.
Right. So, hey, Keith, can I just jump in for 1 second?
Yeah.
I want to move on. Like, I want to get to time on keyboard too. We're at 20 minutes, and I just want to make sure that we actually have time to show stuff as well. And I got to tell you, dude, there's already like 15 questions. So
cool. So let me jump. Yeah. Let me kind of describe what a daemon set is real quick, and then we can jump to a quick operator demo just to kind of give you an idea what this looks like. So a daemon set is where I want to run an instance of any particular stateful service on every single node in a cluster, or all nodes in a cluster that have these particular flags set. In Kubernetes, usually they're called taints, right? So that's very useful. It's generally used for things like backup daemons, Logstash, those types of things, but you can also use them for a database like CockroachDB. And we do support daemon sets, although the operator currently doesn't support daemon sets. So let me go ahead and
1 second. So just before we get there, right? So let me just tie off on a couple things, right? So like to me, StatefulSets is a critical piece because I think there was somebody actually in the chat has already said, and in my opinion, virtually all useful work is stateful. I agree with you. Like anything that's useful in kind of compute, you're going to have state. And so understanding stateful sets and understanding how to use that within your own microservices-based applications is hugely important. Now, there are two things that Keith actually touched on that I think are also extremely important to this kind of pattern of how you deploy software in Kubernetes. One of the things that Cockroach does is that, the Cockroach database itself is its own basic, it's one binary. It's the same thing every time. You don't have multiple different types, so like a write node and thinking about the way that you deploy software as one common thing and then using stateful sets across the board becomes a lot easier because your control and what you're actually tracking in each one of those kind of pods is very similar. Now, keeping that, I think, under control is one of those ways to actually simplify things when you're designing and architecting kind of a services-based application on Kubernetes. Number one, I think that's a great lesson learned from the code base and some of the approach that's been happening in microservices. But understanding stateful sets is actually critical because that is how you actually can remount a volume or, say there's certain sort of temporary state that's going on in that container or pod or whatever. You can actually store that, which is a big deal for stateful workloads. So there's also the concept of an operator. So before we get into you showing the operator, Keith, I'll give my definition of an operator, and then I would just like for you to understand, what we've built in our operator after that. Okay, and so. An operator, the concept of an operator came about, it was about 3 years ago, I think, the operator pattern. Brandon Phillips from CoreOS actually helped drive a lot of this. And I remember they originally wanted to call them like controllers, and I'm like, no, you can't call it controllers. And then I think it was controller. No, they're operators. It's kind of like, how do you mirror some of the mundane tasks that like an SRE would have to do over and over again, but give a framework, an execution framework for that within Kubernetes, so when you deploy, certain configurations have to happen in every single pod. Like, do you want to telnet into each one and SSH and figure out what's going on in each one of these things? Or can you use just an operator and it has control from the control plane out to actually understand what's going on, right? And so operators are really, really critical, especially in applications that are being deployed on Kubernetes because they help kind of simplify a lot of these things. Now, at Cockroach, as Keith mentioned, we can survive failures of pods. We can scale pretty easily by just adding a new instance pointing at the cluster, and we're going to do. But at the data layer, like the data that is in Cockroach is written in triplicate. We're using a lot of the same core principles. We're actually built to be a distributed database, so we actually piggyback on top of a lot of the core principles that are in Kubernetes already. Where we venture off and say, hey, we needed an operator was that, look at over the past year, in Cockroach Cloud, we've deployed thousands of CockroachDB clusters on Kubernetes, and our team has learned a whole heck of a lot in terms of what are some of those gotchas? What are those repeatable patterns of things that we can do and automate and make it easy for everybody to basically run a database that was built for Kubernetes on Kubernetes. And so that brings me to the operator that we have, Keith, and you've been instrumental in not just defining that, but also kind of helping, deliver that. So can you just talk about the CockroachDB operator and, what's in that and where it's going?
Yeah. So a little over a year ago, from some community prodding, some folks had kind of taken our Helm chart and built kind of a nascent Helm operator out of it, but it wasn't working all that great. And so I kind of took it on myself as a side project to create kind of a semi-supported operator that was really just kind of a basic install operator using our Helm chart. Let you do kind of the compostable configuration for a CockroachDB install. And what we discovered, as you mentioned, with Cockroach Cloud and Cockroach Cloud is 100% run on Kubernetes. So all the hundreds, if not thousands, of clusters that we've managed on Cockroach Cloud to date are run in Kubernetes. We've learned a lot about kind of the nitty gritty of running CockroachDB in a Kubernetes-based environment. So the operator itself is effectively best practice implementation. Like we have this, production checklist that's a document on our website. It's effectively that rewritten as code. So for things where you would have multiple steps. So for example, in the first major capability that the operator has is something we're calling seamless upgrades, which means that we'll detect what steps we need to take to upgrade your cluster without any downtime from, say, a particular version X to the next version Y. If that means that we need to do a metadata catalog upgrade because it's a feature release, we will set the database up to maintain both versions of the metadata catalog while we're rolling the pods to the new version. Then we'll finalize the upgrade after the fact for you. We'll stop you from doing things like upgrading too many releases at once, right? Generally speaking, we want to jump through feature releases, right? So you don't want to jump straight from 19.1 to 20.2, for example. You're going to want to jump from 19.1 to 19.2 to 20.1 to our latest release of 20.2, right? So it's those kinds of capabilities that the operator is going to enable us to roll out. Things like, so the database itself can, with 20.2, can schedule a backup, right? But getting the infrastructure mounted into the pod so that backup actually has a place to persist to is actually kind of hard to do in Kubernetes. Right. It's not a problem with CockroachDB, right? There's no, if you were installing on a VM, it would be pretty trivial to install the AWS CLI or the GCP CLI and allow it to mount its object store, but it's just a little bit harder in Kubernetes. Yeah. So I think you're gonna see over the next few months, we're continuing to add capabilities that are gonna make it easy for someone who wants to run CockroachDB in a Kubernetes-based environment to get the configuration set up for those, call them day two operations. Things you need after you're already operating CockroachDB for test and dev, things that you're going to need to be able to take it to production and not have to have kind of a Kubernetes super expert. So I'm going to go ahead and share my screen real quick. Can you see my screen now, Jim?
Yeah, absolutely, Keith. And just real quickly on that point, and our operator and everything is open source. If people are interested in, I know I have links on our website and a couple other spots, and we'll find the links and I'll get them here. We are looking for people to help contribute. There was actually an answer in the QA. Somebody was asking about multi-region and lots of different things. And I think, right now we want to make sure that a single region cluster is working really well. I think that's what it's kind of the state of art with a lot of Kubernetes clusters that I see is like federating clusters and that's a big challenge. Crossplane is trying to help with that kind of stuff, right? Like, how do I So somebody was asking about that, and just to address that, we are looking for people to actually help build out this operator. So if you like Go and you like operators and you like Kubernetes, man, this is a great project to get involved in. So I digress. Keith, can you show us our operator now? I just want to toss that in there while we're talking.
Yeah, absolutely. So I am going to launch our new operator on OpenShift, largely because OpenShift provides a nice graphical interface for launching the operator. So if you're in OpenShift, you got a nice tile. If you're running in another Kubernetes deployment, you have a couple of kubectl apply commands that you need to run. And from our perspective here, it's a couple of clicks. You kind of decide which namespace you want to install it into, and you go ahead and click the install button. And that's going to go ahead and install the operator onto this Kubernetes cluster. So really easy to get it going. If you're in, say, GKE, it's 2 kubectl commands. You apply the custom resource definition, and then you apply a CR that actually launches the operator container. And that exposes a new kind, effectively, that's CRDB cluster. Okay. And once that's there, we can define a CockroachDB cluster and have the operator start it and maintain it for us, and have it look like it's a native Kubernetes service, which is cool both from an operations perspective, right? Because you're not having to do kind of unnatural things like manually modifying manifests for individual pods and whatnot. But it also enables the system to make more intelligent decisions, right? So if you just use Helm to install CockroachDB, right, your initial install is going to be pretty much the same, right? You're going to apply a config. If you were to use Helm, it would be like a myvalues.yaml file that's going to say how many nodes, the resources. In this case, I don't care about the CPU memory. I'm just kind of making sure that I mount a 10 gig persistent volume, right? And I want to make sure that TLS is turned on. Okay. So for our particular setup, I'm going to go ahead and create that real quick. But in Helm, it's pretty much the same thing. It's a Helm install command that, and you could apply a config file and it launches that configuration. The thing that the operator does is, instead of just kind of maintaining that config until you explicitly go and change it, you can set the operator up so that it makes decisions based on monitoring of the application itself. So, so if you noticed, so at some point we're going to get some sort of kind of automatic elastic scale out baked into the operator. So you'll be able to set some form of auto scaling rules where you can say, hey, if you see that we hit 70% CPU across all of our pods, or if you see that we're starting to run out of disk on these persistent volumes, I want to scale out and add an additional pod, or I want to scale out and add 2 additional pods. Scaling back is going to be a little less elastic. We are a stateful service. So generally speaking, I doubt we'll get to a spot where we're going to do a whole lot of kind of scaling in automatically anytime soon. But those are the kinds of things an operator can do that you can't do with kind of the package installer that is Helm, right? So the operator on the back end, it went ahead and it created some stateful sets, it created some resources, created a couple of service endpoints, and it launched 3 CockroachDB pods. So one of the other kind of nice things about being in OpenShift is we get a virtual CLI. So I could do like a
And by the way, there's been a lot of questions about how we scale up and down and all these things, Keith, and how we survive things. We're going to show some of that in a little bit, y'all. About 10 minutes from now, we're going to show you how you can kill pods and the database is still good. So I just wanted to make sure there were several questions like that. So just while you were typing.
No problem. So I just used a terminal and logged into the database to kind of demonstrate that it was up and running, right? So so there's a lot of great stuff that you can do with the operator. If we go ahead and take a look at kind of some of the stuff that's available, there's a bunch of different options I didn't set. I can change my HTTP port. I can set my SQL memory. I can change cache sizes. I've got a lot of configuration options available to me here, some of which we have hidden.
What about security, Keith? I mean, setting up certs and doing all these things, that's typically a difficult process. Yep. Especially when you're deploying a distributed application. Does our operator help with that?
Yeah, the operator manages all of that for you. So it's all I had to do was set TLS enabled equal to true to enable over the wire comms. There's a separate field for doing encryption at rest. I did not turn on encryption at rest for this particular cluster, but that's another kind of flag that we could set. Generally we use different certificates for the over the wire communications than we do for the encryption at rest stuff. That automatically generates some secrets. So you can see that the Cockroach operator itself had some roles. We created a root certificate. We created a node certificate. These are the things that if you were to use the Helm chart, once you do a Helm install, you end up having to go in and as an admin and approve the certificate signing request for each node. And then you have to approve the client certificate for the cluster. Right. So it's a lot more steps to do this with a Helm based install. And we're kind of doing all that out of the box for you.
And that's exactly why operators were created, because if you had to do that 100 times, that's a nightmare. Right. And I think that's kind of the key thing here. So Keith, this is running right now. Is this running against EKS? Is this GKE? What are we running against here?
So this OpenShift cluster is actually running on my laptop, but it's not. Of course, I didn't want to just demonstrate running on my local machine. So I also spun up a cluster in GCP. Yeah. Right. So I have a 9-node cluster that's running across 3 data centers in GCP. We did some manual work to bridge the networks, which, as I think we mentioned, is not yet supported by the operator. So this is a different install pattern here.
I'm sorry. Wait, what networks did you bridge?
We bridged the container networks from these 3 regions. So that all of the CockroachDB nodes could talk to each other. That's the primary requirement.
So this is one second. Let me just get this straight. So we have 3 Kubernetes clusters, but 1 database running on top of all 3. Is that what this is?
Yeah. So we have 9 nodes, 3 nodes per data center running across 3 data centers, and we bridge the networks for these 3 environments so that all of the pods could route to each other.
Right.
So that's the kind of stuff that 12 months from now, we're hoping the operator is going to be able to automatically manage for us. We're certainly not there yet. The operator, we're still adding, as you mentioned, kind of single cluster features. This is probably something that we'll be focused on at some point next year. But it's a really exciting thing that you can do with CockroachDB running on Kubernetes.
Yeah. I just want to put an exclamation point on this, because there is a lot like SIGFED, which is, if you're familiar with the SIGFED special interest group in Kubernetes, I think it's like started and stopped a couple times. Upbound was created to create one cross plane, to create a single control plane across multiple different clusters. The cross-plane project is trying to do that. And that's basically controlling Kubernetes at the operations level, right, Keith? And what we're saying is that, well, why don't you just federate the data above clusters, like still manage 3 clusters, but you can have basically 1 database to manage that's running across those 3 clusters. And that's exactly what's going on here, right?
Right.
And ultimately, the workloads that actually matter have data underneath them. So you could basically now deploy whatever you want from a service load point of view and from your services in each of these regions, hitting any of the nodes within region, but the database is being, even if data lives like on US West or whatever, and you're hitting it from the east on that cluster, you hit one of those nodes in the east, it will know to get that data in the west, correct?
Yeah, right, exactly. So so I've got kind of a more involved demo in this environment that we can work through here. So first thing I'm going to do is I'm going to kill one of the pods. And what you're going to see is very quickly one of these nodes is going to stop responding. Let me go ahead and switch to the list view. So node 2 is now a suspect node. That means it's no longer responding to ping requests. If it were to stay suspect for, say, I think it's 5 minutes, we would then move it to dead, which just means that's going to trigger us to start re-replicating the data that was hosted on that node. I'm going to let that pod restart here, and that's going to go ahead and kind of come back and be healthy again here in the next 20 seconds or so. So as you can see, it's no longer a suspect. And now the under-replicated ranges count is back to 0. And I've got some load running on this database right now. It's like 500-600 queries per second. Performance isn't that great. We're running in the like multiple hundreds of milliseconds for our worst case queries right now. We probably want to do something about that, right? So one of the things that we're going to do is we're going to set some of those rules that you were just kind of hinting at a couple of minutes ago to tell the database how we want to distribute the data. So effectively right now we're randomly distributing the data across the cluster. And what we're going to do is we're going to redistribute the data across the cluster so that it's primarily domiciled, so that the authority to act on any particular segment of the data is co-located with where it's being accessed.
And Keith, that was randomly distributed across all 9 nodes across the 3 regions is the key thing, right?
Right.
So you're going to now segment it so it's actually tied to a region.
Right. So I'm going to go ahead and get this kicked off on the back end. We're not tying it to a region. What we're doing first is we're setting the authority to act on that data to a particular region. Okay. So I'm not moving all of the, say, East Coast data to be on those 3 East Coast nodes. What I'm doing is I'm moving something called the leaseholder, which is the kind of the leader replica for any particular segment of the data. For the East Coast data, I'm moving that to the East Coast. So it's still being replicated to these 3 data centers, right? So
still available in all of them.
So I'm still going to have a replica in each of them, but now the East data is the authority to act on that East data is going to live in US East 1. The authority to act on the central data is going to live in US Central 1. And the authority to act on the West Coast data is going to live in US West 1. So what that looks like from our perspective here is we can go ahead and kind of take a look at the tables here, and we'll be able to see that I've partitioned the index, right? So you see all these kind of alter statements. And then I've set a constraint where I've configured the lease to be primarily domiciled in a particular location.
And the key thing here, Keith, is the key thing, Keith. Sorry, I just like saying that. It all comes down to that primary key and how you set that up, right? Because what we're doing is we're saying, yeah, there's a primary key on the table, but we're also adding kind of the location into that primary key. And that's ultimately how we can control these ranges. You could think of them as shards, I think, everybody, right? But like that's how we can control where they live, right?
Yeah. So live is different. We can use this to control how it lives, and there are certain compliance use cases for that. What I specifically did here was control where the authority to act on that data was.
That's right.
Okay.
The replica set, the 3 replicas.
Right. So I moved the leader for the replicas to the location where it's most likely to be interacted with. So what you can see is as these changes are finalizing, my throughput is going up dramatically, and my P99 latency, that's my worst case query latency, has dropped by an order of magnitude almost. It was at 700 milliseconds. We're down to 60 milliseconds. Now, 60 milliseconds is good enough for a lot of use cases, but it's not quite as good as I would want for a user-facing app like this is a simulated rideshare app. So really, I probably want my P99 latencies to be even kind of better than that. I'm starting to get creep down into the 20s. I kind of want to get it down into the single digits, right? So what I'm also going to do is I'm going to create some secondary indexes that allow me to do kind of some novel things with effectively metadata, okay? So one of these tables in this data model is a promo codes table. So like rides, that's got a good geographical dispersion, right? My rides are going to be, it's most likely a ride record is going to be interacted with from the city that that the ride took place, right? Users are pretty easy to figure out where any particular user is at any given time, but a promo code needs to be fast from everywhere, right? So what I just did is I added some constraints. This will update here over the next 30 seconds or so. Maybe it's user promo codes. Yeah, it's user promo codes. Where what I've done now is added some. I've partitioned the data and then added some additional indexes to that data. There we go. Yeah. So now I have an index that's primarily domiciled in each of the regions. So I've got covering indexes for each of the regions. This slows down my write speed, but luckily, you're not issuing new promo codes every 10 milliseconds, right? But it allows for super fast, blazing fast reads from this table from all the locations that we were talking about. So the net effect of that is now my P99 latency, my worst case latency, is under 4 milliseconds. From like an application design perspective, you generally want your app to be, you want to be able to have your entire user interaction happen in 100 milliseconds or less. Now, even if I had to have 10 of these queries run, I could run 10 queries against the database, plus still have 60 milliseconds for my application to do whatever business logic it needed to do, and still respond to the customer without them feeling any kind of UI lag.
Sure. Yeah. And I mean, it's really powerful what you can do, right? And I guess when I first really understood what we were doing at Cockroach, I think when you typically deploy a database, you're just thinking about the logical model of the data itself, like the keys and with Cockroach, it's a little bit different because you actually want to think through survivability. So Keith showed you killing a node and the database still survives, and you can still kind of have access to all that data, which I think is just killer, right? But then understanding latency and where data lives and where the leaseholder is and these sort of things, it's an added kind of level of complexity when you're thinking about the database, right, Keith? It's like, it's a combination of both the physical and the logical world, I think, is where these things kind of come together. And it is a little bit different in distributed systems, but that's how we have to think about things, because ultimately we're dealing with the speed of light. I will give you, everybody, and I do this on every time we talk about these things. If you're interested in this and a lot of other things, our docs is incredible. I think what our team, Jesse and the team, does with the docs is just, if you really want to walk through and do this yourself, there's very, very good like step-by-step examples of what this is, right, Keith? So I think I talk about docs every single time, but it's poetry. It's beautiful. So there was a question here, Keith, and I want to actually, you are actually one of my favorite people to ask this question too. Some of these concepts are very similar to Cassandra, right? And, I think you spent some years working in the Cassandra part of the world, right? How is Cockroach different from Cassandra? Not just technically, I think there's some things, but like where you would use it versus Cassandra.
So Cassandra is optimized for single record writes and single record retrieval.
Right.
Right. It is a key value store. We use a key value store under the covers to act as our storage engine, but we have a full SQL ACID compliant ANSI standard SQL engine running on top of it. And the big difference between what we're doing and what Cassandra does at a really super fundamental level is we we distribute the data in a lexicographically ordered set of ranges, which allows us to do pretty efficient range scans. At the but what we do is we sacrifice a little bit on the read performance, not a huge amount, right? We were just seeing 4 millisecond reads in our app, right? But we have a 2-step process where we check an index to see what range owns which portion of the key space, and then we go and query a record back from that range. Whereas in Cassandra, they use a hash-based encoding for the key,
Right.
which means that the key location is deterministic, right? So for any given Cassandra topology, you can predict exactly which node is going to have which record if you know what the key is. There are advantages and disadvantages to both. We do actually have a hash based distribution mechanism that you can set as a secondary option for certain use cases, although it's not our default, and we don't recommend it for tables that you're going to be doing range scans against because they'll be super inefficient. But that's at a high level. That's kind of the difference, right? So Cassandra is optimized for single record retrieval, super fast. Whereas we're optimized to be able to handle more complex query patterns. And of course, we have the added benefit of having fully ACID compliant transactions, which is not something that you're going to have in a Cassandra or a Couchbase or pretty much any other NoSQL database.
Right. And I think it's actually, these are some really important points. And, you know, for me personally, I don't think I could ever say anything bad about Cassandra because I always joke that I think the pandemic would really be horrible if we didn't have Cassandra. I mean, if you look at companies like Netflix and Apple and HBO and these companies like stream stuff, like it's powering a lot of those workloads. Is it right for every workload? Probably not, right? And well, I think that's where we're seeing the kind of this shift in the divergence in terms of like, well, there's certain workloads that actually make sense for Cockroach, right?
Yeah, and there are a lot of companies that use both, right? You know, for use cases where your performance is the most important thing, and you don't have a consistency requirement, Cassandra is probably the right solution for that problem.
Right.
But you probably don't want to manage financial transactions on Cassandra if you could possibly avoid it, because there's no transactional semantics. So you have no guarantees that you don't have conflicting transactions trying to update the same key at the same time or any of that kind of stuff.
Right.
So for things like inventory management, you know, accounting journals, financial transactions, you know, those are the types of patterns that CockroachDB is probably the best in the business for right now. If you need to have that combination of scale out, you know, predictable performance as you scale, kind of those types of problems, CockroachDB is probably going to be your best available solution. You know, if it's more of a just a fast access, like, you know, what's the URL for this particular video type of a use case? You know, Cassandra might be the best platform for it.
Yeah.
A lot of our customers use both.
Oh, yeah. And I think that's the thing. It's, you know, understanding where one lets off and the other picks up. I think they're both amazing technologies. And if you're using both, you're doing some really interesting things from a scale point of view. So Keith, there were a whole lot of questions. And first of all, I just want to tell everybody, we're gonna try to answer all the questions post event as well. We do have a Slack channel, so if you want to ask any of these questions, we can always answer them in the Slack channel for sure. But we'll try to get all of them wrapped up and sent to everybody afterwards as well. The operator that we've built, Keith, is that for any cloud? Is it going to run anywhere? Like, did we optimize for one environment or the other? Like, can you just describe that?
Yeah. So it's still technically what we would consider a beta product, right?
Yeah,
So it doesn't have like a fully baked release process yet. It's still actively being developed. We're not necessarily guaranteeing that all the APIs are stable right now. To date, we've tested it on 2 platforms,
yeah,
OpenShift, which is what I showed you today, and then our primary development's actually been on GKE.
right,
We're pretty confident that if you were to take it and try to run it on one of those 2 platforms, that you're going to be able to get the basic functionality of the operator working.
right,
Um, we haven't say tested it in EKS or AKS or Tanzu or Rancher yet. That's not to say that it won't work, but you might find that you need to open an issue and that we might have some bugs that we need to resolve. One of the things we discovered when we were taking the work we've done on GKE and moving it to OpenShift was that the default security configuration in OpenShift is stricter than the default security configuration in GKE.
right.
And so we had a couple of enhancements we had to make around that just to get it to run in OpenShift properly. I suspect we're going to learn those kinds of lessons for each of the platforms, the Kubernetes distributions that we're going to start testing on here over the next
Right.
few months. And that's a great way the community could help, is just kind of kicking the tires and seeing if, what kind of experience they have with the current operator in those different platforms.
I mean, honestly, anybody could go out and use it anyway, right, Keith? I mean, it's all there for use. And so if anybody on this call actually wants to go check out what we did, and then use it, enter an issue, all that, the issue tracking, really all that stuff will be there. I think we'll make an announcement about that over the next week or two. But
yeah, I mean, we're currently
use it.
We're currently tracking issues in the GitHub project.
Right,
yeah. So folks can open tickets against the repository. If you want to try to contribute, we are accepting community contributions. So if anyone wants to roll up their sleeves and
encouraging for sure, right?
Absolutely. So we would love that kind of input. We love PRs and whatnot as as we move forward. There are a couple of really interesting questions in the Q&A. We only have like a minute or 2 left. Do you mind if I try to hit one of them? I was
trying to get them in there. I'm sorry, I was trying to break in, but which one did you want to pick off?
So there was kind of an interesting one around how we did the networking. So we actually have some great docs on multi-cluster Kubernetes. And I actually helped co-author a blog with the Submariner team using Submariner to do multi-cluster networking that we can drop a link in the chat if we can find it. It's published on the OpenShift blog. But what I did for this particular one was we peered the networks. One of the things that Google provides is a nice, easy way to peer the networks across regions. And then we did DNS chaining across the 3 Kubernetes clusters. So we actually even have a Python script that's an example of how we do that. We're hoping that Submariner or something like it becomes a kind of a standard for federated networking across multiple Kubernetes clusters or network peering across multiple Kubernetes clusters. But we're open to other ideas. So if folks have other patterns for enabling a full mesh of network connectivity between the CockroachDB pods, that's something that we would love input on. We didn't use Istio for this. Istio is really interesting on the front end. If we wanted to create kind of a service API for, say, the SQL interface, let's say we weren't running in a cloud environment that had a global load balancer or whatnot, and we wanted to manage external service discovery for third-party applications, something like Istio is a great solution for that. For what we're doing on the back end, because we need all pods have to be able to route to all other pods for node-to-node communication. A service mesh isn't necessarily the best pattern for that. But you certainly could use Istio on the front end to make it easier to manage, say, like your SQL endpoints or whatnot. I hope that answered Martin's question.
Yeah, I mean, I think there was a lot there, and I think I'll try to find. I was trying to find the post in the background, Keith. I couldn't find it, but we'll send the links out to everybody. We've got to cut this off. It's at the top of the hour. Thank you, Keith. I love having like a demo on these sort of things. Really great depth. If anybody does want to follow up on more, again, our Slack channel is a great place to ask all these questions and more. We have a Kubernetes boot camp, which is at this first link, cockroachlabs.com/Kubernetes without the M, sorry, the typo. If you're at KubeCon today, we have a booth. We're in Silver Hall A. Stop by. There's an architecture talk about ranges and how all this works underneath. In a couple of weeks, we're going to be on a webinar with the LF Foundation, with the Linux Foundation, deploying a database on Kubernetes, where we'll get into more detail on this. And then after this, there is a survey that's going to pop up. So I would love for you to take that survey. We try to make these things as great as we can. JP's working on the back end about figuring out who we're going to give this water bottle to, or we're going to have to give away several of them. There's some amazing questions here. And then finally, somebody had asked in the chat what our Twitter handles were. I'm James, Jaymc, and Keith, this is yours, correct? Please make sure I got this right. Keith, you?
Yes, that's correct.
Yeah, okay, great, awesome.
That's right.
So, I was trying to do it out of memory, buddy. Keith, thank you for doing this today. As always, there's just a whole lot of good conversation and some great stuff that you're familiar with, and thank you for helping the audience take questions on all this. Everybody, thank you for all of the questions. Like I said, we're gonna document these. We'll try to answer as many as we can, maybe distill them down and get them out to everybody. But we thank you for joining us today. So Keith, any thank yous and goodbyes?
Thank you very much. Really appreciate you having me. Hopefully everybody learned something.
Yeah, we do really hope this was useful. Again, please do fill out the survey. Help us understand where we can make these things better. But give us great marks if it was great. So, so with that, thank you everybody, and really have a wonderful day. And if you're at KubeCon, enjoy KubeCon.